Hi everyone, my name is Mateo Lopez, a student of the Solution Polytechnic University in Cuenca, Ecuador. So I'm here to present you a game made in Python, developed in Python, that implements artificial intelligence to resolve some problems. In this case, the problem is the enemies that have to go to the earth to attack here, and so we implement artificial intelligence to uh, for make the more small smallest distance or more smaller uh, track between the enemies and the earth. So what we have to do to make it like a game. We have an user that represent some kind of vehicle or some kind of, of machine that have a gun that shoot to the enemies. So we let's start here with the code. In this part, we can see uh, we have to declare the window, then players, then gun, then that that lives, and what more, the enemies. In this case, we have 4 enemies to make this game. Then some image to make to appear where when the user lose. Um, what more? So we have the planets. The planets are some objects that the enemy have uh, to avoid in at the time that they are going to attack the Earth. When when we run the game, you can see these planets. So what more? Anything? No, no more, no more, no more. Yeah, the Earth. This is the Earth that are going is going to be attacked by the enemies. So we have after begin to run before we begin to run the game, we have to declare some the the matrix of distance between the enemies and the earth using some uh, formulas. In this case, we use the Euclidean distance between each point of the matrix that represents the window and the earth. So we in this case have 220 uh, 220 squares in the window, because that we have a 4 that makes 220 interactions to obtain the distance, declare the distance between the Earth and the each point that I have mentioned in the last words. If you can see, we have the square between the math point pole of the distance, vertical of the vertical distance and the horizontal distance. In this case, you can see here the horizontal distance and here the vertical distance. Now we have to implement some algorithm that resolves this kind of problems. I'm trying to say the problem to obtain the shortest distance between 2 points. In this case, we use an IMA package that have a lot of algorithms and artificial intelligence that resolve these kind of problems. In this case, we use the I-star algorithm. You can see we have one method per two methods per enemy that calculates the distances or define the distances and each point of the matrix in the game. In this part you can see all the squares in the matrix, like all these objects in the dictionary represents one square in the game board. If we can see here, this is the game board. All these points is the possibilities where the enemy can be placed at the first state in the game, and they have to go to this point. In this point is going to be located the Earth. So the I-star algorithm obtains the distance between, for example, this point to this point, but the best distance. In this case, for example, if we have 4 planets that the enemy have to avoid at the same time that is going to the Earth. So we have all the points in the game board, and this is the matrix connections between each point to her neighbors. For example, the first square is connected to the second square and the 21 square, and the same thing is going to be made to all the squares in the game board. The seventh square is connected to the 6th, 8th, and 27th square. That's represented in all these points. We have the connections to all 220 squares. So we have to do run when we applicate the I-star enemy used all this information to obtain the best distance in between 2 points. So that's what's happening in this part of the code. What more have here? That's the planets that the enemies have to avoid in the game board. What more? So we declare while that never give up to for the reason that the games is going to be executed ever. So we instantiate we begin instantiate the player, the planets, and we begin declaring some method, some conditions, like if the like we have a timer that's going to refresh all the distance or all the points that the enemies have to track between them and the planet. So even 22,500 milliseconds, we refresh the enemies positions, and the extra lives, because if the player collision to the enemies, the player have to be rest one life. The player begins with 3 lives, so the end of the game is when the player lost his three lives. So, but so we have a timer that generates an extra life uh, for the player. What more we have here? The that refresh the enemy position. One more we have here. We ask here if the enemy is still alive. If it don't, if it means that the enemy was destroyed by the player. So the enemy have to be have is necessary to refresh the position of the enemy to a new position in the game board, because the player shoot them. So we do that in this part of the code with the enemy, with the first enemy, second enemy, third enemy, and the fourth enemy. If the enemy is still alive, so we just have to refresh the position using the same algorithm that I have talked about you in this code, and this code using the R-star algorithm for that implements artificial intelligence. What more have we have here? We have to refresh the all the image that is presented in the window, like the player's image, the extra live image. What more? All the image that is presented in the window. So when the players have 0 lives, or the planet have 0 lives, enter in this condition, because it's supposed to the game have the game ends. So we have to permit the player to restart the game or quit the game. So if the player press in the keyboard the letter N, and all the lives of the player have to be replaced. The lives of the earth have to be replaced. We have to refresh the enemy player earth lives, the player lives, and we have to refresh the positions of the enemies. Why we put in this lives false? Because if we put false, it means that that in some time have to go to this condition to no this condition no this condition to these conditions that ask for the state of the enemies. If the state is false, generate a new position to all the enemies. Yeah. What more? In this in this in this in this class, in this text we have all the classes that are going to be necessary in the game, like the players and all the all attributes, the game board, all the squares in the game board, the enemies, the planets that the enemies have to avoid, the earth that is going to be attacked by the enemies, the guns, the extra lives, and in these classes we use these methods. Why? Because we have to ask every time that the enemies have to have collision at to the earth, or if the enemies have to collision into the player, or if the enemies uh, uh, maybe have collision into the bullets that the players have shooted. What more, in this we have here we have the K events that validates if we press the up K, down K, left K, right K of the combination of of this case to move the player inside the window. So let's start it, and let's start the game. If you can see here, we have the player that can shoot the enemies. If the bullet collision to the enemies, in this place we sum the score of the player. But if the player is collision by the enemies, we can see here that oh damn in this part we can see the enemies that the player lives is going down, and if this lives going to 0, you lose. Okay, of the or the air lives going to 0, you lose too. So if we want to play again, we just press the letter N, and the game starts again. We can see here we are shooting to the enemies. The enemies is have the track between have the best track between the earth and his position. We can see here we lose again because the earth lives was going down. So if we want to close the game, we just press the X letter. In this case, we press I press X, and that's all. The game is closed. So that's all. Thank you for watching. Yeah.